Little secrets can actually make a world of difference. Being the greatest requires thinking beyond the box, and SpaceX is committed to keeping its position as the leader in the space industry with an incredible microscopic secret that makes its heat shield the best. Elon Musk announced his achievement on X, formerly Twitter, saying that he and his team had created a super technique that would enable the SpaceX heat shield to endure extreme heat pressure from space and return to Earth's atmosphere without suffering harm or losing lives. Despite obstacles, SpaceX continues to innovate and revolutionize space travel. Today, we'll take a closer look at these incredible tiles and discover the intricate details that allow SpaceX to conquer the fiery challenge of re-entry. Buckle up, let's get started. The secret behind the dependability and security of SpaceX spacecraft during re-entry into Earth's atmosphere lies in their extraordinary heat-shielding tiles. These tiles are more than just high-tech components. They are a marvel of modern engineering, packed with microscopic innovations that make them the best in the industry. Designed with a sleek, rectangular shape and typically black in color, they have a smooth, matte surface, making them visually distinct. They are relatively thin and lightweight, optimized for efficient thermal protection. Their design and material composition are tailored to withstand extreme temperatures and the harsh conditions of re-entry into Earth's atmosphere. For these special purpose, their manufacturing processes are taken very seriously. All stages are intentionally accomplished, from the manufacturing of silica fibers to the application of sophisticated coatings and many other incredible procedures that combine to create this magnificent wonder. So, are you ready to learn how these amazing tiles are made? Not only will explain their manufacturing processes, but you will also discover that SpaceX's re-entry sections are made possible by this amazing technology and artistry, which is currently the best in the industry as we speak. Let's start by looking at the advanced ceramic materials that are used in making this world-class technology. These sophisticated ceramic materials are the central component of SpaceX's heat-shielding tiles. Imagine ceramics that can handle temperatures hotter than a volcano. Obviously amazing. But what exactly are the functions of these ceramics? Now, it is these ceramic materials that form the basis of SpaceX's heat-shielding tiles. The main basis for these materials is silicon carbide or related substances, which are renowned for having outstanding heat resistance. For example, silicon carbide can withstand temperatures above 2700 degrees Celsius, 4900 degrees Fahrenheit, and has a high melting point. This makes it the perfect option for the intense heat experienced upon re-entry. As interesting as the high melting point feature may seem, what's even more interesting is the low thermal conductivity of these ceramics. This characteristic is essential because it guarantees that heat absorbed by the tile's exterior will not readily transfer to the spacecraft's interior. The tiles essentially serve as a barrier, keeping the spacecraft's critical systems and components safe from the extreme heat. This is pretty cool. Then, there's also a microstructure design. This is a key element influencing how effective these tiles are. The controlled porous microstructure of the tiles has several functions. The first benefit of porosity is that it lowers the tile's overall weight, which is important in aerospace applications where every gram counts. The tile's strength and thermal insulation characteristics remain intact despite their decreased weight, guaranteeing their ability to endure the severe re-entry conditions. Microscopic fibers embedded in the ceramic matrix are essential in augmenting the tile's overall toughness. By serving as reinforcement, these fibers stop cracks from spreading. The extreme heat cycling that the tiles experience during re-entry can lead to stress and cracks. But the fibrous reinforcement makes sure that if cracks do occur, they do not propagate and jeopardize the tile's structural integrity. You can imagine this as a sophisticated spiderweb. Next up, we are describing its ablative properties. Have you ever heard of ablation? It is a fancy way of describing controlled erosion. An additional crucial component of SpaceX's heat-shielding tiles' effectiveness is their ablative qualities. Ablation is the process of removing or eroding material by subjecting it to intense heat and shear forces. When exposed to the extreme heat of re-entry, the tiles are made to erode in a controlled way. This is a dual-purpose, controlled ablation. First, thermal energy is absorbed and released by erosion. The heat is carried away by the outer layers of the tiles as they are eradicated, keeping it from soaking deeper into the tiles and entering the structure of the spaceship. Second, the tile's surface develops a layer of char as a result of the ablation process. This layer of char acts as an insulating barrier to further stop heat transfer, offering extra thermal protection. Moving on, there is thermal expansion management. Materials can expand and contract due to temperature fluctuations, which can be problematic in space. As a result, regulating thermal expansion becomes essential to the heat-shielding tile design for SpaceX. The tile's constituent materials are chosen and designed with a low coefficient of thermal expansion, CTE. This indicates that there is little variation in the material's size when the temperature varies. Because it reduces the possibility of heat expansion and contraction, which could cause fractures or structural failures, this feature is essential. Additionally, the tile's microstructure include mechanisms to deal with microcracks that arise naturally as a result of thermal stresses. Stress can be released by these microcracks without sacrificing the tile's overall structural integrity. The microcracking mechanisms are actually very vital. Another factor is reflective coatings. SpaceX's heat-shielding tiles have surface coatings that improve their thermal performance even more. In order to help reflect radiant heat away from the spaceship, reflective materials are frequently put on the tiles. Materials such as silicon dioxide or other reflecting ceramics can be used in these coatings. These coatings lessen the thermal burden on the tiles by reflecting some of the heat, which keeps the spacecraft cooler. Thermal resistance can be further enhanced at the microscopic level with the use of nanocoatings. The purpose of these nanocoatings is to shield the tiles from chemical reactions and oxidation, which can happen at high temperatures. Because oxidation can degrade and lessen the efficiency of the tiles, the nanocoatings are essential to preserving the tile's integrity during re-entry. And lastly, thermal barrier layers. A few of SpaceX's heat-shielding tiles are constructed in layers using various materials to offer gradient thermal protection. With a specific purpose in mind, each layer is created to provide a comprehensive thermal management system. Usually ablative, the topmost layers are made to erode and disperse heat. These are covered with insulating layers that prevent heat transfer even further and safeguard the spacecraft's underlying structure. It's similar to having several layers of protection against the heat. So, what are the manufacturing techniques? Let me start by saying that the manufacturing processes employed in the creation of SpaceX's heat-shielding tiles are equally as crucial as the components themselves. The creation of silica fibers is the first step in the manufacturing process. High purity and consistency are ensured during the creation of these fibers through a carefully monitored procedure. A ceramic composite is created by weaving the silica fibers together. In order to give the tiles the appropriate strength and flexibility, this weaving procedure is essential. A ceramic matrix is then used to fuse the woven strands together, creating a sturdy but lightweight framework. The intended tile methods are formed out of the ceramic composite. Precise cutting and shape are required to guarantee that every tile fits precisely into the spaceship. For the tiles to consistently offer thermal protection, their thickness and size must be the same. After the tiles are shaped, their surface is coated with carbon silicon carbide. Usually, sophisticated methods like chemical vapor deposition or plasma spraying are used to apply this layer. By using these techniques, the coating's distribution and bonding to the tile are guaranteed, improving the tile's resistance to heat. To make sure it satisfies SpaceX's exacting quality standards, every tile is put through a thorough inspection and testing process. In order to confirm the tile's performance in harsh environments, thermal and mechanical testing are conducted in addition to visual checks for any surface flaws. Before being used, each batch of tiles that is created is certified. In order to verify that only the best tiles are put on the spacecraft, a sample of tiles from each batch is subjected to destructive testing. Attaching the tiles to the spaceship is the last stage. To guarantee that every tile is correctly positioned and firmly bonded, this technique calls for accuracy. In order to accommodate the expansion and contraction of materials during temperature changes, the attachment method must permit small movements. But are these heat-shielding tiles actually applicable in the real world? The answer is yes. Most definitely, they are. Real-world uses have shown that SpaceX's heat-shielding tiles are effective. Numerous spacecraft, such as the Dragon capsule and the Starship prototype, have made use of the tiles. These missions have validated the design principles and production procedures by offering important information into how the tiles operate under real-world re-entry conditions. However, SpaceX is still investing in the advancement of innovative heat-shielding systems. The business is investigating novel materials and production processes in an effort to improve the tile's functionality even more. For instance, investigation into cutting-edge coating methods and innovative ceramic composites may be able to increase the tile's longevity and thermal resistance. Furthermore, SpaceX is looking into methods to make the heat-shielding tiles more reusable. Even if the existing tiles are made to withstand many re-entries, material qualities and manufacturing techniques may be improved further to increase the tile's lifespan and lessen the need for replacement and maintenance. SpaceX's heat-shielding tiles represent a remarkable achievement in material science and aeronautical engineering. Their effectiveness can be attributed to a variety of factors, including precise microstructure design, controlled ablative qualities, thermal expansion control, reflecting coatings, and cutting-edge production techniques. SpaceX's heat-shielding tiles are among the best in the industry because of these little secrets, which have allowed the company to conduct extensive testing and continuous improvement. And that's where we draw the line in today's episode. I'll be dropping another video soon about space and science. In order not to miss out, do well to subscribe and hit the bell icon to get notified when it drops. Don't forget to like, share, and leave your thoughts in the comments section. Until next time, stay blessed. Thank you.